Welcome to a lesson with Dr. Powell. In this video, I wish to give a visual demonstration, even a three-dimensional one, and I'll show that in just a minute. But just to preface it, if we're thinking about a run, an ultimate rise, but we're taking a look at the run kind of in skewed dimensions from where we're actually heading, where we're actually going, where maybe in the expression, maybe only one thing changes and the other one doesn't. And then we go back to where the one thing changes and the other one doesn't, then we should collide right here so that we get, because ultimately we'll get to the point where both of the different expressions have gone the amount they should in the proper course. So when I'm looking at that though, think about what's happening. I have a rise over here, and then I go this way back and I have a rise over here. Notice that we have three lines right here, one right here, and one coming down right here. Those three lines in themselves lie in a flat plane. Now look at this plane right here. You see how we have a description of right here. Let's see. This is being the change, maybe the change of X when A is changing. This is the change when B is changing. And we get just kind of get this ready here, and we get right here. This is kind of the slope for that funny function GA that we were talking about. That's the rise of it. And this would be the slope of the tangent line to the funny function GB that we were just talking about. And we get that those rises here together ultimately equal. So this change and that change for A changing, B changing, get back to what actually happened where they both changed for the real DX right here. And we'll ultimately get the real rise right here. Notice how we come back and we get a plane being formed from here, 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 and here. So to kind of view this, kind of think about what's happening here. So this is underneath. Okay, that plane. So we're going this way, that way, that way to get back to what actually is happening. This is a visual demonstration that the two rises actually add together, which ultimately means the derivatives will add together, especially if you're thinking of the same run. The same run in X, but kind of pointed in a different direction. And the same run in X pointed in another direction for a different function idea should take you back to the place that we desire right here, where we had a run of dx and the ultimate rise to get there. And that's because the change in A and the change in B together. So these guys together, the change in A or the change in the A direction and the change in the B direction for those two functions ultimately should give us the exact same run that we originally wanted, where they were changing together to get in the end what they are at the end. This visual demonstration is very nice because it can be expanded. This exact same idea is very applicable if you move not just from two boxes in your expression, but even three. In fact, you could even do 4. You could do 5. You could do a myriad of different things. You could even do 6. put a box right here if you wanted. There's all kinds of things that you could do in building your expressions. Just make sure that when you do it, you don't actually put one box directly inside of another. And in that way, we can, so we won't do that in general, just as a rule of thumb. So, but this exact same principle holds that we were just talking about. We just get the sum of different derivatives, just assuming that one box is a variable at a time and the rest are constants. Thanks for watching.